Okay, here we go. We're finishing 2.4. We're being focused today. If you're not going to focus, I'm just going to, like, send you to your dean, and that would be great. Because, like, I love you as a person, but right now, it's tough. It's tough to love you when you're not helping your grade, and I'm trying to do your grade for you. Okay. Example 4. Okay, so say hi to Spencer and Hannah. Here you go.
Hi, Spencer. Hi, Hannah.
Okay,
Feel better, Hannah.
okay, cool. And commence. Okay, commence. Example 4. Let f of x equal 1 over x. Did we do this one? No. Okay. My guess is this is going to take minimum of 15 minutes to finish the lesson. No, this is it. I'm going to move you. I'm moving you next time. If you can't show me, you can be like, controlled, sitting over there. You're going to be over here. Right here, right by Maya, right in front of me. That'd be great. It's the worst spot. Yep. You were. Alright, so let f of x equal 1 over x. Find the slope of the curve at any point x equal a. Where does the slope equal negative 1/4? Alright, so let's think about the waste of 10 minutes in the class, and we have not started. Cool. So, 1 over x, it is a hyperbola. Hyperbole is in English, hyperbola is in math, hyperbola. Cool. 1 over x. So what we're looking for is the slope at any point. So maybe right here, looking for the slope. Remember how we do our tangent line? Tangent line at any point. I would like to know what the slope is. Alright, so for part A, little rewind. How do we find the slope at any point? Well, you pick one point, aka the point you're looking at. Well, here I'm going to say, how about right here at my A? And I pick a second point that's very, very, very close. Remember how we picked, how we do a tangent line versus a secant? So I come up here. If I pick a point that's very, very close to the point I'm interested in, literally the gap between them is h. And as that gap shrinks to 0, as the distance between my 2 points shrinks and shrinks, eventually those 2 points are literally indistinguishable. Oh. So our secant line, right, the line that connects to my 2 points on my line, literally turns into a tangent line. Okay, so guess what? This is why I'm pointing this out, is this guy right here I'm going to be using below. Take 2 seconds, look at it. Okay, cool, it's in your notes. So for part A, right, I'm going to be using m. My slope is going to be the limit. Why is this so slow? Limit as h goes to 0 of, of f of a plus h minus f of a all over h. Okay, well we know our function is 1 over x, so I'm going to plug in a plus h, n for x, I'll plug in a, n for x. So I'm just rewriting my line, but instead of having it in function notation, I'm actually plugging it in for the function. So I have 1 over a plus h minus 1 over a all over h. So this is really ugly, no bueno. Ideally, we would like to combine the fractions on top. How do you combine fractions? First, we have to do what?
Denominator.
Common denominator. Common denominator. Okay. So I think Elliot said cross multiply, so I'll multiply by a over a on the left. Multiply by a plus h over a plus h. So this turns into, I'm literally going to try to write every step for you. Okay. So I have a minus h all over a plus h times a. Yeah, times a all over h. Okay, so what I did was notice I have this subtraction sign, so subtract, that's why both of these are negative right there. Trying to preemptively answer your question so we understand why they're negative, so I distribute that negative sign. Okay, and then a minus a, that goes away. And I would like to rewrite this just so it looks a little simpler, so maybe you can see what the next step should logically be. So I have negative h over a times a plus h. Instead of dividing by h, I will multiply by its reciprocal, 1 over h. And guess what happens here? H cancels out. Okay, I'm going to take a little pretzel break for a second so you guys can write. Because I see you like frantically writing. Yes.
Get it.
A squared plus a h. Yeah.
Can you do it? Yes, thank you. Do you care if we write a limit on
Yes, I do.
on
Elliot, repeat your question one more time.
what?
Repeat it one more time so everyone can hear.
What? Do you care about the limit if we write limit h approaches 0?
Yes, you must write it every time. Aha, so I had him repeat it so everyone could hear. That was your chance. It's in the screencast. We said it twice out loud just today. Before we said it out loud again. Okay. Okay. So now if I sub in 0 for h, right, and the limit turns out to be negative 1 over a times a plus 0. That's just negative 1 over a squared. So our slope turns out to be, I don't know why my pen is just being all crappy today. Negative 1 over a squared. Maybe.
Don't we have to plug something in?
Yeah. Negative 1/4. But look, A says find the slope of the curve at any point. This is at any point. B says, hey, what about when it equals negative 1/4? Okay, well that's the chillest thing. Yeah. Yep. There's this tallest question. A to negative 2 is the same thing as 1 over a squared. Okay.
So for where does it equal negative 1 over 4? And we say it equals 2.
Well, let's see. So I want to know for part B, where is the slope equal to negative 1/4? So I have negative 1/4 is equal to negative 1 over a squared. So literally I'm looking, where is a squared equal to 4? Well, if I square root both sides, plus or minus 2. Plus or minus. So when you are introducing the square root, right, when you're introducing it, because there wasn't a square root before, when you're solving and you have to square root something, you have to have the positive and negative. But if you were evaluating, I gave you a square root and a number and you like plug in and solve, compute, you can do whatever. But when you introduce the square root, you have to have plus and minus, yes?
Why don't you plug in negative 1/4 into negative 1 over a squared? So it's negative 1 over negative 1/4, and then you multiply and it becomes 4.
Whoa.
So where does the slope equal 1/4? So if m is the slope, I set negative 1/4 equal to negative 1 over a squared. What do you mean plug into the equation? This is not, negative 1/4 is not my A. Yes.
This, right?
Yep.
Why not plug that into there?
Well,
So it's over, instead of a squared, it's over negative 1/4. Then
it's not, because the 1/4 is not my A. 1/4 is the slope, it's not the x value.
So then how do you know to do that?
So here I had m was equal to negative 1 over a squared, and B was asking, where is my m equal to negative 1/4? Oh my god. So I set these two equal to each other, because B is asking, where is your slope equal to negative 1/4? From A, we know slope was negative 1 over a squared. We're trying to solve for A, the values of x at which the slope would be negative 1/4. Well, yeah, difficult. Okay. Let's try the next one. So at what point is the tangent to f of x equals 3 minus 4x minus x squared horizontal? At what point, so this is saying x equals what? At what point is the tangent, wait, so this is saying the slope is going to be horizontal. So the tangent, the line is going to be horizontal. What slope is that going to be?
I'm thinking.
Slope of a horizontal line.
So it's just gonna be y.
Slope of a horizontal line is 0. So we're finding, we want to know where is the slope equal to 0.
3. Everywhere. 3. If it's horizontal. No, because you plug in 0 and just make it x squared and the negative 4x squared and whatever. But it's everywhere.
What? No. What does this look like? What does this look like? Negative x squared is pointing down.
Yeah.
So I want to know, where is the tangent going to be 0? Probably at the vertex.
I'm factoring.
0,3.
No,
Why?
it's not.
Yeah, wait, I got it. -3 and 1.
I was thinking that. I don't want to say that though.
Not quite.
What?
Not quite.
It would be negative.
Okay, so let's go ahead and let's find slope. Why is this? This is. Okay.
Isn't the slope going to be 0? It's 3 and 1.
3 and negative. Wait, -3 and negative.
It'd be 3 and 1. That's what we do. 3 and 1.
What's the x value for where it's horizontal?
What for 1 and 0?
What's the x value when our slope is 0? Slope of the tangent line.
-3 and -1.
No.
3 and 1.
That is where the function has a y value of 0, not the tangent. That's not where the tangent has a slope of 0. Okay.
Oh, do we have to do the f of a?
Yes.
How do we know to do that?
Because it says the word tangent. You use this for tangent.
Oh.
It says average or secant. That's when you use the more or less slope formula. Did I put it on the other page? I did not. It's literally the slope formula for secant. Why did I scoot back so far? Shouldn't have done that. Continuity. Man, I went way too far. I meant to only go here. Average rate is your secant. Remember? A secant touches your graph at 2 points. Secant. So it's just your average slope. You take your start, your end, line between them. That's your slope. Versus tangent is that it's only touching the 1 point versus the secant. The average touches at 2 points. Okay. So I have this. Let's go ahead. Let's plug in x plus h into this whole function. So I have limit as h goes to 0 of 3 minus 4 times x plus h minus x plus h squared minus 3 minus 4x minus x squared. So just plugging in. So this first one, I just plugged in x plus h everywhere I saw an x here. And then the second one, I just literally copied the function value down. Okay, so let me just rewrite it. So 3 minus 4x minus 4h. Let's see, x plus h squared. Do we remember? Exactly. Don't fall to the shortcut of x squared plus h squared. No. This is a binomial. You must FOIL it out. X squared plus xh plus xh plus x squared, or h squared. Okay, so this whole thing right here. So then I have to minus all of them. Minus 3 plus 4x plus x squared. Don't forget to distribute this minus out. And same way here, if I had a minus sign in front of it, like I do right here, I have to distribute the minus out. All over h. Okay, so I like wrote it out. Now I'm going to see if anything will cancel. X squared goes away, 4x goes away, 3 goes away. Awesome. And then, I mean, I could do it all in one line. I could, cancel out the h, but I want to make sure we all see where it is coming from. Negative 4h minus 2xh minus h squared all over h. So every single one of these terms have an h in them. So if I put h equals 0, okay, let me rewrite this. I'm sorry, I tried to go a little too fast. Negative 4 minus 2x minus h. And if I plug in 0 for h, I get negative 4 minus 2x. Okay, so I found this is the equation for the slope of the tangent function. This is the slope of the tangent function. And wait, what is this question actually asking? Go back. At what point? What does x equal? When my slope is 0. So wait, if this is the equation of slope, I want to set this equal to 0. I'm going to set this equal to 0, so I have 0 equals negative 4 minus 2x. Add 2x on both sides. 2x equals negative 4, divide by 2. X equals negative 2. Awesome. So, at x equals negative 2, my slope of my tangent is 0. That's the point I'm looking at. I'm going to zoom out so you can see it all. So tricky. You might be tempted to do you remember how to find a vertex? Negative b over 2a. Negative 4 over, negative b over 2 times a. So this is 4 over negative 2. Oh, negative 2, what do you know? Double check. So that was like a quick check. We understand what this function looks like. This is a negative x squared function. Where will I have a tangent that's flat? Oh, at the vertex. Finding the vertex, negative b over 2a. So that's negative of negative 4 over 2 times negative 1. We found the same x value. That's the nice thing of giving you a problem you already should know how to solve. We know what the answer should be, so showing you this way, double check. We're on the right track. Okay, that looks gross. I'm going to erase it because that's not nice. Okay, do we need a little more time to write? Are we okay? I see everyone is done writing. Okay, last page of notes. Woohoo! So, normal to a curve. What does it mean to be normal? So think about in geometry. If you have a perpendicular bisector, it's normal to a line segment. Normal means 90-degree angle. It means perpendicular. The normal line to a curve is the point at which the normal line to a curve at a point is the line perpendicular to the tangent at that point. Okay, cool. So think about my example earlier. I'm going to erase this, so don't draw it. But if I had a parabola and I was wanting the tangent that was horizontal line of 0, if I want the line that's normal, it's going to be at a 90-degree angle. So this would be the line that was normal at a 90-degree angle to my tangent line. So I'm trying to show you, what should the steps be? Okay, cool. So we will go and find the slope of the tangent line. And wait, how do you find perpendicular?
The reciprocal.
Yeah, opposite reciprocal. Cool. Opposite reciprocal. Okay, so kind of talked about how we're going to do it. Let's try it out. So I have this one function. I want to find it at x equals 1, whatever. First, we have to find what is the slope of the tangent line. So I need to zoom in a little more. So I have m is equal to the limit as h approaches 0. I think my battery is dying.
Yeah, it said battery low.
No, that was my computer. It's alright, almost, close. So I want to add x equals 1. So at x equals 1, this is going to be my a equals 1. So I'm finding it at a point. Okay, so what this means is limit of f of 1 plus h minus f of 1 all over h. Actually, I think it's because I have too many things open on this. Oh, that was definitely it. It's taking up too much memory. I had like 5 documents open. Alright, limit as x approaches 0. Let's see, f of 1 plus h. So what I'm going to do is plug this in for my x. 1 plus h, I'm plugging in for x right here. Oh, check it again, right here. Okay, cool. 4 minus 1 plus h squared minus 4 minus 1 squared all over h. I want to make it clear, like literally the 1 plus h, that's why I plugged in for x. And then I made sure I had to copy over the total equation. Alright, limit as h approaches 0 of 4 minus 1 minus 2h minus h squared minus 4 plus 1 all over h. Okay, so I did skip a couple steps there. What? What's 0?
You don't do like minus 2.
Negative 4 plus 1 is negative 3. No. Right, it all cancels out anyway. So make sure we're clear here. So I had a negative sign in front of, let's see, 1 plus 2h plus h squared. So that's where all my negatives came from right there. Okay, so the 4 goes away, the 1 goes away. And wait, I could cross out one of the h's. No, wait, let me back up a sec. That was not okay.
No, that was good.
Yeah.
Oh, the one's gone.
Yeah.
Good job.
Then it's negative 2.
You can take out his 8.
Yeah.
Okay, so now that those canceled out, every single thing has a factor of h in it. So I see limit as h approaches 0 of negative 2 minus h. Well, that just goes to negative 2. So that means, my slope of my tangent line is negative 2. So, if I will... But I'm not done.
Because that means when x is 1, y is 3, and then you can put it in point slope form.
Pause. Wait. We want the normal slope, the perpendicular slope, right?
So it'll be 1/2.
1/2. It is the opposite SIGN. We switch the SIGN and we flip the reciprocal.
So the normal is
What's
always
SIG?
So what is that?
What?
Sine?
Yeah. Because when I say sine, I don't know if you're...
Oh, like sine, like a sine.
Yeah, because that's what I'm going over with my pre-cal right now. This is what I'm saying to make sure we're on the same page. Okay, so when x equals 1, let's see, y equals 4 minus 1 squared, which is 3. So I have a point 1 comma 3. Point slope is our bestie in this class. Remember, I just plug that guy in and we're good.
So it's y equals 1/2 x plus 2.
Cool. Like, that's all you actually have to put.
Oh, what?
Woo! Okay. And lastly, our last question. And then we're going to get right into asymptote practice and stuff, okay? Okay. So speed revisited. So if you look at the very first problem we did in this chapter, the function y equals 16t squared that gave the distance fallen by the rock in 2.1 was the rock's position function. A body's average speed along a coordinate axis for a given period of time is the average rate of change of its position, aka we talk how that's the secant. Its instantaneous speed at any time t is the instantaneous rate of change of position with this, or guess what? This is how we were talking about our tangent. Tangent is instantaneous. If you want average, it is secant. I think that's about the 50th time I have said it. Woo! Alright, so what are we going to do? Let's find the speed of a falling rock with this position function at time equals 1 second. Wait, so at 1 second, I'm wanting it at one specific instant, so I'm going to use my instantaneous speed, my instantaneous velocity. Very, very similar to what we just did above. Alright, so my slope, my rate of change, my speed is going to be the limit as h approaches 0 of f of 1 plus h minus f of 1 all over h. Now remember, our function is y equals 16t squared. So I will plug these in to my equation. So I have 16 times 1 plus h squared minus 16, because 1 squared is just 1, all over h. So I have 16 plus 32h plus 16h squared minus 16 all over h. So I simultaneously did 1 plus h times 1 plus h and then distribute the 16 out. We see that the 16 goes away. And if I would rewrite this, exactly, I can take out the h just to make sure we are groovy with where this is coming from. Groovy, yay, okay, yep, take out the h. So I see, okay, well guess what, the limit as h approaches 0 of 32 plus 16h is going to be 32. So that's 32 units per second. Oh my god, right. Oh. Units per second, and the exact same thing we found on the first problem. Cool. Okay. Yes.
Can you do it the other way and then put in t at the end?
What?
Like where you do t plus...
Oh, yeah, where you find equation?
Yeah, like you do 16 times t plus h squared. Yeah, cool.
Yep. Okay, check one, done. Now let's go through this guy. Will you pass one out to her? And give me the extras. So, this is something that should help you. Woo! Yeah, exactly. That's exactly what it is.
Can we add like the other formulas on it?
What?
Yes, I add the other formulas on it? Like the slope.
Oh, I don't care. This is just like to help you study.
He was right behind her. He saw her hold on. Wait, I have a question.
Thanks. Is there only one left?
I could have given.
Did everyone get? Everyone only has one, right?
Here we go again. Here we go.
I don't think I put this in one. No, I don't think they should do that. But everyone only got one, right?
Yeah.
Did everyone only got copies? I'm so confused.
I got one.
Wait, you got the
answers?
29, 10, 11, 12, 13, 14. I think 14.
Mr. Brian, are a lot of these formulas like the same, just with different rules? On the notes? So like,
Yeah.
so like speed, is it the same as slope of a curve at a point?
Yeah.
But it's just in different contexts, is that what it is?
Yeah. Okay, so I want to go over this. This is more or less like a cheat sheet. It's what we've talked about multiple times. This talks about horizontal asymptotes and vertical asymptotes. Okay, so if the degree of a numerator is less than the degree of a denominator. So my example for this one, degree of numerator is less than denominator. So if I have like 5x squared over 6x to the fourth, guess what? Leading term test. That's literally leading term test right here. That's how you find horizontal asymptotes. Let's throw back. Remember how we were learning like limits and stuff? Okay. So that's when you have, oh, well, clearly, if I would rewrite this, this is 5 over 6x squared. Bigger on bottom, your horizontal asymptote is 0. If they have the same degree, so my example for this one is like 7x to the third over 2x to the third. Oh, interesting. They have the same degree, the same power. So it's the ratio of leading coefficients. So here, it'd be 7 over 2. And that the degree of numerator is greater than denominator. So for example, if I have like 13x squared over 4x, this literally turns into 13x over 4, and it doesn't actually approach a number, it goes to infinity, and that's why you don't have a horizontal asymptote. So this is something I've written like for you. We've gone over it a couple times already in chapter 1 and chapter 2 now. But it should be a cheat sheet for you. And this is for rational functions. So remember, rational functions is you're literally taking a function divided by a function. Maybe like 2 polynomials, 2 lines, whatever. And then vertical asymptotes. So if you're able to cancel any factors, then there are points of discontinuities, holes, removable discontinuities. So you write it so how do you actually find vertical asymptotes? Write it in simplified form, aka in fully factored form. And then cancel out any factors you can. Please don't play tic-tac-toe. I'm going over this. Okay. So you have to fully factor. If anything cancels, that's a hole, removable discontinuity. And then if there's nothing else that cancels, you look at all your denominators and you set each equal to 0 and solve, and those are your vertical asymptotes. Okay, that's a little cheat sheet for you. Just gave it to you. Hopefully it's useful. I would like to go over some of the like 2.4 practice. I have a lot of like practice stuff. Right now. I'm giving it to you. All 3 of these practice things, the solutions are online. So.
Will we be doing this to practice test as well?
What?
Will we be doing this to practice?
No. I wanted to go through the asymptote practice and 2.4 practice. Do you know the pass one after them? You pass one after them? Yeah. Where you pass one after? Oh, sorry. So there's lots of practice. My idea was, try to get more done today. Sorry, there's so many papers.
You were really mad at me when I came late to one of your games last year, so you threw my test at me.
Whatever.
You were like this, like this.
Like here.
Yeah, he broke it.
Okay. So I think we could knock out the asymptote practice right now. We still got 8 minutes. Thank you. The asymptote practice is literally 6 problems. Let's do that one as well. Yeah.
It's 3.
Yeah.
I got 4.
Can we just do it? It's not what that is.
Well, this is like the cheat sheet for it. Sorry, I don't know. The solutions to everything I just handed to you are online. Asymptote practice, online. Chapter 2 practice test, online. 2.4 extra practice, online. Okay. Asymptote practice. Okay, whatever. Chapter 2 review, I thought I put the solutions online. I forget. For sure. Alright, so let's go through and let's just use what we just went over. We should be able to knock this out in no time. Fine. Horizontal, vertical asymptotes are the following functions. So, let's find the horizontal first. Using leading term test. 2. Y equals 2, since they have the same degree.
Yay!
To find vertical asymptotes, though, I have to fully factor it. So I have 2 times x squared minus 4. All over x squared plus 5x plus 6. Hopefully that helps us factor a little bit.
X plus 5, X plus 1.
Not quite.
2x minus 2.
X plus 2, x plus 3 on bottom.
X minus 2.
X plus 2, x minus 2 on top. So what does this mean for this one factor right there that is crossed out? This is a whole. So at x equals negative 2, I have a whole.
It didn't ask for
Right. But I'm making sure you understand it. So when I rewrite it, I know that to find the vertical asymptote, I have x minus 3 left. So for my vertical asymptote, I have x plus 3 equals 0. So I have a vertical asymptote at x equals negative 3.
It's always the bottom, right?
Yes. Perfect. Okay. So, let's try the next one. Here we go. Let's look at the leading terms. This is technically a 1 and a 2. What's my horizontal asymptote?
0.
Exactly. Bigger on bottom is 0. Y equals 0. Now let's see if I can cancel anything out. So let me fully factor this out. Nothing cancels. It sucks. So how many vertical asymptotes will I have? 2. 2 vertical asymptotes. And I have to set each of these equal to 0 and solve.
Is that just 1/3 or no?
Negative 1/3. Awesome. Okay, what about the third one? None. So we write none. I just gave you a case of all 3 that were on your paper. Who would have thought? Okay. And if I fully factor this out, let's see. X minus 6, x plus 3. Set each of these equal to 0.
6 and 3.
Yep, x equals 6 and x equals 3. Those are the equations of my vertical. Yeah, that should be a positive 3 and that should be a negative 3 right there. Yeah. So these are the equations of my vertical asymptotes. Perfect. So I'll move up a little bit. And now we're just finding the limit. Wait, limit as x approaches infinity is the,
-1/6.
we're looking at leading term test. So I'm looking
It is negative
here,
1/6.
here.
Negative 1/6.
Negative 1/6.
That was actually, that was really easy.
How about this one?
well,
0. How about this one?
Zero, none.
The limit does not exist.
What?
Because I'm looking at the limit as x approaches infinity.
But isn't it
Since-
flash standing?
Well, yeah. Infinity
It's fine if we don't write that.
does not exist. Yeah, that's fine. Infinity does not exist. Okay, see, I told you we could knock this out. So, for tomorrow, ready? Here's the plan. I'll let you go a minute early. Here's the plan. You're walking. We're going to go through the... I wanted to go through the extra practice. We'll go through the practice test, and if we have time, we'll go through the extra practice for section 4. I'll see you guys tomorrow. Yeah.